Assalamualaikum warahmatullahi wabarakatuh. We are from Group 3. We present our topic, which is Pharmaceutical Clean Room. First of all, I will introduce our group members. Start from myself, Adam Majdi, then Akilatul Rade'ah, Siti Nushada, Nur Afifa, and lastly Muhammad Firdaus. And here is our content.
I will continue with the introduction. So, what is the definition of clean room? A pharmaceutical clean room is a controlled environment in which the concentration of airborne particles is minimized to ensure the manufacturing or processing of pharmaceutical products in a sterile and contamination-free environment. Clean room standards typically cover aspects such as air cleanliness, temperature, humidity, pressure differentials, and personal cleaning. The design and classification of clean rooms may vary depending on the specific requirements of the pharmaceutical process conducted within them. Moving on to the Ministry of Health MOH policies related to sterile preparation facilities with a specific focus on clean rooms. Ensuring the highest standards in sterile pharmaceutical preparation is paramount, and this begins with the qualification of clean room facilities designed and constructed in adherence to good preparation practice GPP requirements. Firstly, clean room shall be designed and built by experienced clean room contractors. The proposed layout plan, grades, and control parameters shall be submitted to the Pharmacy Practice and Development Division of Ministry of Health for approval prior to the development of the facilities. Upon commissioning by the contractor, clean rooms and their major equipment, which are lamina airflow cabinet and cytotoxic drug safety cabinet or isolator, shall be tested by an independent third-party agent for confirmation of compliance to standards. The testing agent shall be accredited by appropriate accreditation bodies such as National Association of Testing Authorities, Australia, or National Environmental and Balancing Bureau, USA. Prior to use, clean room facilities shall be inspected and qualified by auditors from the Pharmacy Practice and Development Division, Ministry of Health, Malaysia. Next, clean rooms under directional airflow cabinet and cytotoxic drug safety cabinet or isolators shall be maintained regularly according to approved and preventive maintenance procedures. The maintenance shall include through cleaning and testing by the accredited testing agent. Hence, microbial monitoring shall be done regularly depending on the usage of the facilities and outcome of the test result. Lastly, qualified clean room facilities shall be inspected routinely by auditors from the Pharmacy Practice and Development Division, Ministry of Health, Malaysia, at least every 2 years.
When designing a pharmaceutical clean room, prioritize efficient material and personal movement. Separate processing areas from corridors, ensuring distinct access points and unidirectional flow. Sterile preparation facilities need dedicated air handling systems with alarms for personal safety. Maintain 24-hour pressure differentials without cooling during non-use. Ensure well-lit clean room with 500 to 600 lux for comfort and efficiency. Use flush-mounted seat light features that can be serviced from above. Install watertight flush-mounted electrical outlets that are easy to clean. For layout, clean room is an area for sterile preparation activities that may consist of either CDR facility, non-CDR facility, or both. Premises and utilities for CDR facility should be separated from non-CDR facility. A recommended total built-up area of 1,200 square feet should be made available for a complete set of clean room facility. For specifications, choose construction materials carefully for floors, ceiling, and walls in facility design. Ensure resistance to sanitizing agents and clean spray surface to prevent dirt accumulation. Select material that resists chipping, shedding, flaking, oxidizing, or deterioration. Use curved junction between walls, floors, and ceilings for easy cleaning. Avoid horizontal fixed pipes or conduct over exposed components, materials, and product surface. Flush service fitting with surrounding surface and install airtight ceilings, walls, closed fitting doors, and seal light fittings to optimize the HVAC system.
Environmental control in sterile pharmaceutical preparation facilities. First, building finish and structure. Its design should minimize particle generation. Wall, floor, and ceiling should be smooth, non-porous, and easy to clean. Then, air filtration. It is a critical aspect of clean room design. HEPA filters are commonly used to remove particles of various sizes from the air. Next, air change rate. It is the number of times the entire volume of air within a clean room is replaced per hour. The higher cleanliness levels requiring more frequent air changes. Then, location of air terminals and directional airflow. Strategic placement of air terminals ensure uniform and controlled airflow within the room. It should establish specific airflow patterns to prevent the accumulation and spread of contaminants. Then, room pressure. Positive pressure is maintained in clean room to ensure that air flows out of the room and prevents the influx of particles. Negative pressure may be employed when there is hazardous substance within the room. Next, particulate loading. It refers to the concentration of airborne particles in the clean room. Monitoring systems like particle counters are used to measure particulate levels within acceptable limits. Then, temperature. Maintaining a specific temperature is crucial for stability in manufacturing process, as temperature fluctuation can affect the performance of sensitive equipment. Then, relative humidity. Its specified range of 55 plus minus 5% ensure a controlled environment that minimizes the risk of electrostatic discharge and other humidity-related issues. Next, pressure differential. The specified range of 10 to 15 Pascal ensure that the pressure differential are sufficient to maintain the desired airflow patterns without causing discomfort to occupants. Then, material flow. Material airlocks and cleaning rooms are used in the transition of personnel and materials, ensuring that only proper sanitized and controlled items enter the room. Then, personnel flow. The movement of personnel into and within the clean room involve proper gowning procedure and designated pathway. Training of personnel ensure adherence to cleanliness standards.
Now I will be discussing two essential pharmaceutical facility designs, which are cytotoxic drug reconstitution, CDR, and non-CDR layouts. So, imagine the CDR facility as a fortress dedicated to handling potent cytotoxic drugs. So, the layout prioritizes containment with a clean room featuring a negative airlock, ensuring hazardous materials are securely isolated. The air handling system is robust with a non-recirculated AHU and emergency response buttons for spill control. Seamless, easy to clean flooring, changing rooms, and isolators underscore our commitment to personnel safety. The non-CDR facility, on the other hand, is adaptable and flexible, accommodating various sterile preparations. Positive or negative pressure isolators are deployed based on the drug type, with room grading ranging from grade B to at least grade D. Environmental control is precise, maintaining sterility while adjusting parameters as needed. In essence, CDRs is fortress, focusing on stringent containment for cytotoxic drugs, while for non-CDR is chameleon, adapted to handle a spectrum of sterile pharmaceuticals. So, both layouts prioritize pharmaceutical safety and efficacy tailored to the specific demands of the drugs they handle. So, I will explain about the airlocks for personnel and material in a clean room. So, in CDR facilities, the material airlocks adopts varying pressure, which are 30 Pascal in the production area, 15 Pascal in the airlock area, and 0 Pascal in the general area. So this strategic pressure design, along with controlled airflow from the production to airlock and then the general area, effectively to prevent contamination. So, moving on to the stage personnel airlocks, pressure are meticulously set at 45 Pascal in production area, 30 Pascal in gowning area, and 50 Pascal in changing room. So, the progressive reduction in pressure coupled with the controlled airflow from the production to gowning area and then the changing room ensure a systematic containment of contaminants. So, lastly, in the containment airlock, pressure are different, which are 50 Pascal in the production area, 0 Pascal in containment airlock area, and 50 Pascal in airlock area. So this tailored pressure arrangement along with the airflow from the production to the containment airlock and then the airlock safeguards the environment. So now let's explore about the types of materials that can be used for clean room construction. So for the types of materials that can be used for the floor, like epoxy, polyurethane, resin, which are creating a seamless, non-porous surface with anti-slip features and prevent the bacterial growth. And moving on to the walls, the example of materials are polyethylene, which is low maintenance, durable, and resistant to shading. And for the ceiling, heavy-duty like polyurethane panels provide stability with the added benefit of utilizing space for above for ducts, service pipes, and HEPA filters. Testing. So this material selection ensure to a sterile environment, durability, and compliance with the stringent standards.
Okay, I will tell about the clean room plates. I will simplify all of this so it will be easy to explain. So for grade A, ISO class 5, it is a highly controlled environment for aseptic manufacturing. The filtration used for this is G4, F9, and H14 filters. HEPA filters terminally located for this one. For grade B, ISO class 6, facility with recirculated or 100% ambient air. Filtration for this is G4, F9, and H14 filters. HEPA filters is terminally located. For grade C, ISO class 7, the facility with recirculated or 100% ambient air also. The filtration is G4, F8, and H13 filters. The HEPA filters terminally located. For grade D, ISO class 8, that is potential for cross-contamination. The production area with potential for cross-contamination. The filtration is G4, F8, and H13. Filters for final particle removal. For grade D, ISO class 8, the production area using 100% outside air. The filtration is G4 and F8 filters for cleaner incoming air. And lastly, for pharmaceutical unclassified control area, ISO class 9, the basic production area with HVAC. The filtration is G4 filters for basic air quality. That's all.